need to debug why a specific client is getting errors, or track which requests belong to which users in your FastMCP system. You'll see how to extract critical request metadata, like unique request IDs and client identifiers, directly from the FastMCP context, giving you the visibility you need to trace, log, and debug interactions in real time. At MCP, tool. Async def request info CTX, context, dict. Return information about the current request. Return. Requested, CTX request ID. Cliented, CTX, client ID or unknown client. This demonstrates the context injection pattern for request-aware processing. The context object provides a standardized interface to access request metadata, logging, and cross-cutting concerns without polluting your function signatures. What makes this distinctive is how it decouples your business logic from infrastructure details while maintaining full access to the execution environment. The pattern works through dependency injection, where the framework automatically supplies the context object based on type hints. Your function declares what it needs via the CTX, context parameter, and FastMCP handles the instantiation and lifecycle management. This creates a clean separation where tools focus on their core logic, while still having access to request-specific capabilities like progress reporting or client metadata. This approach solves the common problem of how do I access request data without making my functions framework-specific. It keeps your tools portable and testable while enabling rich interactions with the execution environment. The trade-off is that context methods are async only, which means your functions must be async even for simple operations. But this ensures consistent behavior across all context capabilities. Let's break it down line by line. At MCP, tool. Async def request info CTX, context, dict. Return information about the current request. This defines an AI callable tool using FastMCP's decorator pattern. The @MCP tool decorator exposes this function to AI models, while the type hints and docstring automatically generate the tool's schema. All FastMCP tools should accept a context parameter for logging and progress reporting. Return. This begins returning a dictionary response, the standard format for FastMCP tool outputs. Structured data ensures consistent parsing by AI models and downstream systems. Requested, CTX request ID. This includes the unique request identifier from the context object. FastMCP automatically generates this ID for each invocation, enabling traceability through logs and monitoring systems. Cliented, CTX, client ID or unknown client. This uses Python's short-circuit evaluation to provide a fallback value. If CTX, client ID, is falsy, it defaults to unknown client, ensuring the response always contains a valid string. This defensive pattern prevents missing data from breaking downstream processing. This closing brace terminates the dictionary literal and the function body, completing the tool's implementation. It ensures the function returns a properly structured response that FastMCP can serialize for the AI model. Contextual tool design. The RequestInfo tool demonstrates FastMCP's minimalist context pattern, where a single decorator transforms Python functions into AI callable endpoints while preserving type safety and async capabilities. The cliented field defaults to unknown client when none, which subtly masks missing client initialization from the response schema. This pattern proves that AI integration doesn't require sacrificing Python's native type system or async support.
The tool that knows nothing of its caller answers everything about